We're going to be covering part 2 of section 1.2. So we'll label this as 1.2, part 2. This is the second half of the properties of real numbers. So the reflexive property, it is a value always equal, a value always equals itself. So A equals A. Examples of this: 16 equals 16 for mathematical, or 5x equals 5x. Like when you look in the mirror, reflexive is kind of like reflective. You see yourself in the mirror. 4y squared equals 4y squared. Next, symmetric property. This is if A equals B, then we can say B equals A. So they flip sides of the equal sign, okay? Flip sides of equals is kind of what happens. So examples would be if x equals 3, then 3 equals x, period. Or you could say if 5x equals 30, then you can also say 30 equals 5x. You'll see these properties come into play a whole lot more in geometry because you have to label what's happening when you flip which side of the equal sign things are on, even though it doesn't change the value of what's happening. And the last one to talk about, transitive property. This is if A equals B and B equals C, then A equals C. It's like it transfers from one to the other. So you could think of transfers from one to another. So mathematical examples are example, if 4 plus 3 equals 7 and 7 equals the square root of 49, they're both equal to 7. So then 4 plus 3 can equal the square root of 49. Period. Now, I said the last one, but that's the last one where we have examples written like this. This is where we kind of have to show. So we're talking about the closure property. To determine if a set is closed under an operation, if the operation always produces an element of the same set. So produces element of the same set. If an element outside the set is produced, so if we have something that's outside the set is produced, then it is not closed. So in other words, if it makes a false statement, okay? So not closed would make a false statement. So if we look at number 1, integers are closed under multiplication. Yeah, if I multiply integers together, that's always going to give me another integer. So this is true. If I look at natural numbers, so we're looking at natural numbers are closed under subtraction. Well, I'm not so sure about that because natural numbers, remember, those are all of the positive values, whole positive values except for 0. So if we came up with the example of 5 minus 9, That gives me an answer of -4. Well, that's false because -4 is not a natural number. So this is false because -4 is not a natural number. Even numbers are closed under addition. So if I think about anything, if I had two even numbers together, 2 plus 4 is 6, 4 plus 4 is 8, 16 plus 16 is 32, I always get another even number. So therefore, this is a true statement. Irrational numbers are closed under division. Well, the most common irrational number is pi. So if I'm doing division, that means I'm going to be doing pi divided by pi. Well, if I did 5 divided by 5, that would give me 1. So pi divided by pi is going to equal 1. 1 is a rational number. So this is false because 1 is a rational number. Therefore, it is outside of the set. It is outside of the set, so therefore it is not closed. It's false. It's a rational number. And perfect squares are closed under subtraction. Okay, well, perfect squares, that would be like 25, and I'm doing subtraction. So 25 minus 4, well, that equals 21. But 21 is not a perfect square. So this is false. And here's our counter example, because it asks us to give a counter example, which was what I have done every time it has been false. When it's true, I don't have to provide an example. False because 21 is not a perfect square. Thank you and have a great day.